All right, guys, welcome. If you're still with me and you're still watching this, it means that you are interested in just taking a little bit of a look at what's going to happen in grade 10 for physics. And I'm just going to relate it back to what we would have done in the very last unit of grade 9. You've done some physics work before in grade 8 when we did work calculations. We've done a lot of physics work in math without really even understanding it. But when it comes to science, there's a few little things that I want you to take a look at. And if you're watching this video today, you're actually going to get a real sneak peek into what's going to happen in physics 10 and then relating it back again to just what we would have done in grade 9. So basically the first thing I want you to do is to make sure that you have some paper out in front of you and a pencil. It will be the best way to actually do this work with me because it is math. It's kind of like doing a math lesson, and I will write the answers down eventually, and you'll probably just want to try to pursue this stuff on your own if this is interest to you. So the first thing I want to talk about is this page right here that you're looking at is basically part of the formula sheet that you'll get in grade 10. And it has all of the physics formulas that you will need. And I just want to talk about reading these tables before we get started. So something that's really important that we have to understand is that we often have, like in the front here, it says non-SI units used with SI. And SI usually is just like the standard unit that we use in just our science and our math. And so you look at here, sometimes it'll ask you for time, sometimes it'll ask you for hours, and so we use a unit symbol H, and they want you to know that 1 hour equals 3,600 seconds. And in physics, something that we didn't get to and that you do in grade 10 primarily is just do some conversions between like hours and seconds and stuff like that. But looking through this formula sheet, these are all of the formulas that you will use in grade 10. And so I just want to talk about how to read this table in case, something happens and you don't get a very clear explanation of it. So I've written the names of the formulas beside each one. So the words that I have written there, like velocity, the formula is V equals D over T. And this little line just basically means the velocity moving forward. So you don't need to worry about that right now. You'll learn about that stuff in grade 10. But that's how I've written out the things, just so that you understand. I want you to take a look and note that something that's really important is that every letter in this table, okay, has a meaning on this side. And something that I do when I tutor is I realize that people don't understand that, like, you might be like, well, what is V? Like, what is that? You can just actually go over to this side right here and recognize here that V is velocity and it's measured, it tells you what it's measured in meters per second. So I really want you to take a look at that. Every letter in this formula sheet has an answer on the other side for what it is. So D is distance, and it's measured in meters. So the idea here is that you never really have to memorize all the units and what everything means and what it's measured in, because it's here on the table, and it tells you what the name is and what it's measured in. In science, something that's different from math is that we use units, and these units in the back here, meters per second, meters, seconds, meters per second squared, kilograms per meters over second squared. Just there's a lot of different types of units that we need to use, and that's super important. Okay, so looking at formulas, you need to understand that they're math. Okay, so everything here is math, and it's not even hard. A lot of this math is three variables, and usually you'll get two numbers, and so you're just doing one step to solve for the answer. And a lot of times when people go to science, they think, I can't do physics because it doesn't make any sense, but it is just math. This one here, just to explain it, acceleration equals velocity final minus velocity initial. That's what VI and VF mean. And so then you would do some subtracting. And what that means is when we're driving a car, the velocity when it's going the fastest is its final speed. And initially, it's going to go slow, right? Because it's going to accelerate. And that's why that formula is about acceleration. So if you're wondering what those mean, again, you can just go through the formula. This little triangle thing here means delta, and it just means change. So whenever you see a delta in front of something, a little triangle, it just means the change. So this one here would mean the change in some sort of an energy or energy potential or gravity or something like that. So just so you understand that. But anyways, that's what we're looking at, okay? Down here, what I've written right here are two formulas that we would have used in our unit this year, Ohm's law, which has to do with voltage, which is measured in volts, which is a V. And actually, I'll just write volts here for you. And then, so it's V equals I times R, okay? So that's the formula. So voltage equals current, which is actually represented by the letter I, times resistance. And resistance is measured in this little ohms thing. So I just wanted to show you the units below and the simple formula that you use to solve the to get the answer. Another thing we would have looked at this year is energy, and energy equals power times time, P times T. All right, and so you have it down here. Energy is always measured in joules, power is always measured in watts, and time is normally measured in seconds, which is why on the top of your formula sheet here, it tells you how many seconds are in an hour. Okay, so that's kind of cool. So these are all the formulas we're going to work with, and this is the stuff that you can be doing if you're pursuing this. So the first little bit here just talks about working with formulas. It says in physics you must be able to manipulate formulas to solve problems. Most formulas are given to you in standard form, so one version, and it's up to you to move the variables around when solving the problem. So I just want to talk about this concept scientifically, and then I want to look at it mathematically. So in Science 10, something that gets really confusing is that your science teachers are going to tell you that you have to take a letter formula and you have to change it around and change around the letters in order to solve the math problem. But what I'm going to tell you is that that's not always the case, that you can actually just use the numbers and plug them in and solve the problem the same way that you would in math. This is a huge thrower offer for a lot of people that go to Physics 10, and it actually can drown a lot of people and cause them to be so confused. So just understand that doing math or doing the science and manipulating the formulas are the same thing. So here's a problem that they have. They have a formula and it's E equals mc squared. So that's an Einstein formula if you've ever seen that before. So it says the formula asks us to find E, but what if we're given a problem that asks us for M or for C? So sometimes, guys, you're going to need to be finding these variables. We've done this in math before. We need to move the variables around to isolate the one that we're looking for. To do this, we'll move the variables to the other side of the equal sign by doing the opposite. So guys, what's going to happen right now is I'm going to show you how to manipulate formulas in letters. And because I think this is something that your science teachers are going to show you, but then I'm going to show you just how to do the math and how simple physics actually is. So the first thing that they're going to look for is the letter M, so that's mass, and so we start with E equals mc squared. So we've got to get the M all by itself. So the first thing that these guys did is, because this means when they're kissing, it means multiply, they're going to do the opposite. And so they do the opposite by dividing out the c squared and putting it on the other side. Okay, do you see how I did that? So now the m is all by itself. So if you see here, E over c squared equals m. Now, guys, if you were to put the the E value in here and the C value in here, and it would give you that on your question, so don't worry too much. You're like, what the heck are those things? What does that mean? It would give you those values. We'll look at that in a second. You could throw them into this formula and you'd solve for M. But I just want to tell you, too, that that it's not always like that. We can just do that with the numbers as well. So here's another way to manipulate specifically a letter formula looking for just C. Now, we're just looking for C, and there we have C squared. Interesting. So I'm going to write down the steps that we would do here. We would take our formula, E equals mc squared, and we want to get C all by itself. So the first thing we do is we recognize that this means multiply. So this means multiply, so we have to do the opposite. We divide we divide the m out because we want the c squared to be all by itself. So we divide the m out and we put him on the other side. So now we have E over m equals c squared. Now this is kind of just like the Pythagorean theorem, like we're not done because we're looking for C. So what's the opposite of squaring something? Is square rooting it, right? So what you got to do is you got to get in here and you got to square root that and square root that so that the square goes away. And what you have is you have the square root of E over m equals the answer for C. So guys, this is what we call manipulating scientific formulas without numbers. But you can actually just put the numbers in there, and I'm going to show you how much easier it is when we look at it that way. Just remember that when we go to science in grade 10, all of a sudden math becomes essential. And the opposite operations, in order to get through science 10, we've got to really be able to remember the opposite of multiplying is dividing. The opposite of adding is subtracting. The opposite of squaring something is square rooting something. So these are important things to remember in order to survive science. So if you want to give this a try and pause the video, you can go ahead and do these, solve and rearrange these formulas. So solve for A using this formula right here, force equals mass times acceleration. So I'm going to solve these, so you're just solving for these letters that they've said here. And so if you want to try those on your paper, you can go ahead and pause it, and I'm just going to keep walking through to show you how to do it. So the first one, we have the formula F equals M times A, and it wants me to get A all by itself. So what we notice here is that this is multiplying, so what I'm going to do is divide, because it's the opposite, and I need A by itself, so I'm going to take out the M by bamming it and put it on the other side. So the answer here would be F divided by M would give us A, and so then we could actually just put the force and divide it by the mass, and you get the acceleration. B says that they want me to solve for the letter V. And so what I've got to do is so I'm looking for V. So what I got to do is I got to get V all by itself. So because that's multiplying, V times T, I'm going to take the T out, bam it, put it on the other side. And the answer here is V equals D divided by T. Cool. And then C here, I'm going to solve for G. E equals MGH. 3 letters in a formula now. So guys, now what we're solving for is the letter G. So what I need to do is I need to get G all by itself. And so this is important. So I want him to be all by himself. So I need to, this is multiplying. Whenever numbers are kissing, whenever they're side by side, we're going to divide out the 2 that aren't. And we're just going to bam those out. Do you see how I did that? And I'm going to put them on the other side. So the answer now, G is by itself. So G equals E divided by MH. So I could put my gravity number in here, my energy number in here, my mass number in here, and my height, and I could just do the formula, E divided by MH, to get the answer. Here's the next one we're going to do. It's solving for D. So we're doing velocity final equals velocity initial plus 2AD. Oh my goodness. Okay, so this is now math. So I gotta get stuff away. Okay guys, so this one might seem kind of weird to you, but what I need to do is I need to get D all by itself, which is this one right here. So order of operations says that I need to, this is an adding thing right here, if you guys notice, this VI plus. So I'm gonna subtract VI from this side, and I'm going to subtract VI from this side. So I get VF minus VI equals 2 times A times D. Now I need to get A and D away, 2 and the A away from the D, because I need the D all by itself. So I'm going to divide by the 2A and divide this by 2A. And guys, look, I got this hard formula. D equals velocity final minus velocity initial divided by 2 times acceleration. Do you notice how what I'm doing here is I'm playing with numbers, but I'm actually just moving stuff around. The very last one here is probably the hardest one, which is E. And so I'm solving for V when E equals 1/2 times mv squared. Okay, so guys, I actually don't like the way that this formula is written, because this ensues that it's 1/2 times that. But what I'm going to do is I'm actually going to write it like this. Because 1/2 means divided by 2, I'm going to rewrite the formula and go mv squared divided by 2 and kind of take this part out, because I don't like that. I don't like how it looks. Now this is like the math I know. This is the stuff I've been doing in Math 9 my whole life. This is what I was made for. So I'm trying to solve for the V. And so I need to get the 2 out of the bottom. Well, guys, this is just the math you've been doing. Times that by 2, so now we have 2e equals, and then we have mv squared. Okay, I need to get the v by itself, so I need to bam out the m. So then I have 2e divided by m equals v squared. I'm just going to start to erase some things here. Actually, no. I can just do my last step. And okay, so my last step is to get v all by itself. Do you notice how this is v squared? So we need to make sure that we get it to v, so we square root that, And I'm sorry, guys, I'm just going to write the answer right here. The answer is V equals 2E divided by M. Square root that. Bam. And so now I could just throw my letters in and get that. So that's physics at its best. So guys, now what we're going to do is we're going to go through some of these questions, and I just want you to try to do and solve some of these problems. So I want to show you how to do the math side of things because I like it better. It's just my preference, but you have to use units. So here's how we do physics problems when we solve things. A current of 25 amps passes through an electric heater when it's connected to 100 volts wall outlet. Okay, so basically what I get everybody to do is, it says, so what is the power of the heater? Oh, sorry, so we're doing power, my bad. So this is not Ohm's law. This is power. So, oh no, wait. What is the power of the heater? Just wait. Let me just come back here. Let's take a look. There is one here. I think it meant to say what's the resistance of the heater. So I'm just going to change that. Resistance. Okay, cool. So you got to always go back to your formula sheet to figure out what we are using. So I told you that we're using Ohm's law. So the thing in science that I always get people to do is to write down on the side what you have. Okay, so the V. Do we have V? Do we have volts in here? Yes, we do. And so I write V equals 100 volts. Then we have 25 amps. That is current, and current is the I, okay, guys? So we would write an I here, and we would write equals 25A. And we don't have the resistance, so I would go like this, okay? So I always do that first. The second thing that we do is we write the formula and fill in the blanks underneath. So we have voltage, which is 100 volts here. We have I, which is 25 amps here, times the resistance, which we don't know. Okay, do you notice how I wrote that? I'm solving for R, so I'm going to divide by 25 amps, cross that out, divide by 25 amps. 100 divided by 25 on your calculator equals 4. So the resistance equals 4. But here's the kicker, guys. We've got to write what resistance is measured in. And if I go back up to my notes here, you're going to see that resistance is measured in ohms. So I'm going to have to write this symbol after because science always makes you write the units. So if I go back here, the resistance is 4 ohms. So just to go through the steps that I did, I wrote out the formula, figured out which one I needed. I wrote out my box full of what I knew. I wrote out my formula, put my math in, and super easy to solve, you guys. Physics is not that hard. So the next few questions are these types of questions. If you want to pause it and go ahead and do them yourself, you can go ahead and do that, or you can just keep watching and and I'll just keep kind of showing you how to do this. What is the potential difference across a light bulb that has a resistance of 30 watts when the current passes through is 5 amps? So again, I told you, we know that we're using the voltage formula. We make a box and we write down what we know. Do we know V? Do we know I? Do we know R? Okay. This is sorry, so this is a different formula. Let's ban this out, sorry. Okay, so we're using power now, my bad. So watts and amps. So actually, I don't even know if we have this one right now. Let me just check if I have it in my thing. Okay. Oh yeah, actually, sorry, never mind. Yeah, watts and amps. See if I have one that has watts and amps. Oh yeah, power equals I times V. Okay, cool. So there's a new formula here. Sorry, so let me write that for you. Power equals I times V. Okay, so this is power. This is current. And times voltage. Okay, cool. So now that I've told you what all those mean, do you think you can solve this now? So we're going to make our box, and we're going to do power, I, which is current, and V, which is volts. Okay, so we have 30 watts. So guys, power is always measured in watts, so we'd put 30 watts here. current here is 5 amps, so you'd write 5.0 amps here. And voltage, what is the potential difference? That always means voltage, so we're looking for voltage. So then we fill in the blanks. So first we write the formula P equals I times V. We write down 30 watts equals 5.0 amps times volts. Okay, how do we solve for volts? Well, we do the opposite of multiplication, which is divide. So we divide by 5, divide by 5. 30 divided by 5 is 6. So the volts equals 6. And we always have to write what it's measured in, so you'd write volts right there. Bammo, whammo. Okay? So this one asks me, what's the resistance of a heating coil of an electric heater if a current of 24 amps runs through it? Okay, so we're going to use this voltage formula. We're going to make a box. Guys, this is a great time for you to just try this on your own. Can you do this by yourself? Okay, so V, I, R. Okay, so volts, we have 120. Amps, we have 24. Resistance, we don't know. V equals I times R, and you would go 120 equals 24 amps times R. And then in order to solve for the variable, we have to do the opposite of multiplication, which is divide by 24, divide by 24. And so we look here, 120 divided by 24 is 5. Resistance equals 5, but it doesn't just equal 5. Remember that resistance is measured in ohms, so we'd have to write in ohms here for that extra mark. Okay, guys, the last one you can totally do by yourself. So pause it, do the math, see if you can do this physics, ace it. So again, I'm going to make my box. I'm going to write out what I have, V, I, and R, and I'm going to see that I have 0.2 amps. I have 4,800 ohms, and I don't know my voltage. So I'm going to write my formula out, V equals I times R, and I'm going to fill in what I know. I is 0.2 amps times 4,800 ohms. I'm going to go 0.2 times 4800, and I get 960, but I can't stop there because I'm doing it in volts, so I would write V for volts. Cool, guys. Last one here for voltage. Okay, again, write out what you know, so this is a good time to pause it. Try to finish this if you haven't already done it. I, R, okay, and so this is amps, 0.06 amps, 12 volts, and I don't know my resistance. So you'll notice, guys, that this is pretty simple. You're just filling in what you know. I is 0.06 times resistance. Divide by 0.06 amps. Divide by 0.06 amps. So 12 divided by 0.06 amps is 200. So the resistance equals 200, but again, we don't stop there. We always have to say what it's measured in for science, and it's ohms, and that's that. So guys, the next formula is velocity, and so speed is always when it asks you for the speed, it's asking you for the velocity. So I'm using a formula from the formula sheet up here for velocity. So I went up to this velocity formula right here, and I brought it back down because I knew that's what I needed to use. So we come back down here, and so it says that we're using velocity, and so we're going to do the same thing, and this is actually Science 10. So I'm going to make my box. And I'm going to write out what I have. V, do I have speed? Okay, so speed is velocity. No, I don't. Do I have the distance for D? Distance is 4.0 times 10 to the 6. And then do I have my time? Yes, I do. I have time. It's 3.6 times 10 to the 4 seconds. Now, guys, on your calculator, you can put this in. Remember that the house is to the power of. So if you were going to write like 4.0, you would go 4.0 times 10, house 6 to get that. Or you could just move the decimal 6 times and multiply it, because we know that we're going to move the decimal 6 times when it's that. So I'm just going to show you the math here. So write the formula again, D divided by T. Okay, let's write out what we have. We don't have velocity. We do have the distance, 4.0 times 10 to the 6, or it would be 4.0 and we'd move it 6 times. 1, 2, 3, 4, 5, 6. Fill those all in with zeros. Put the new decimal here. Divided by 3.6 times 10 to the 4. Oops, sorry, so divided by 3.6 times 10 to the 4. You can literally just put this in on your calculator, you guys, or you can do this. So if 1, 2, 3, 4, I'm just gonna do my zeros. So I'm gonna go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Divide that by 3, 6, and then there's 3 zeros, and I get my answer is my velocity is 111.1. Now, because I'm not familiar with the units that velocity is measured in, I'm going to go back up to my table and I'm going to find out that V, I'm going to look for V, so here it is. It's measured in meters per second. So that's what I would write down here. I would write meters per second. And that would be my answer, 111.1 meters per second. You're going to be doing sig divs and stuff like that in grade 10, but at least you know how to do it now. Okay, so here's another velocity one. You can probably do this one all by yourself. If you're practicing with me, you can just pause it and go ahead and do it and write out what you have. So the velocity is speed, so 6.9 meters per second for 4 seconds. Calculate the distance. Okay, cool. So I'm going to write my formula like I always did, and I'm going to fill in what I know. 6.9 goes here, equals distance I don't know, and time is 4.0 seconds. Now guys, see how the math in grade 9 works out here. We got to get the 4.0 out of the bottom. How do we get it out of the bottom? We put brackets. We put the 4.0 on the top. We bam it out. We multiply it to the other side. 6.9 times 4 is distance equals 27.6. Again, we got to take a look at what distance is always measured in. So we go back up to our formula and we'll see here that D is distance. It's measured in meters. So I go back down to my formula and I put a meters there and then I'm done. You can totally do the next one if you want here. It's a different formula. It's acceleration. So we're using a totally different deal. So we're using A. So shuttlecraft accelerates from rest to a velocity. Ooh, we have A, V, and T. Okay, so velocity must be V, so that's 50 meters per second. So notice how I'm filling it in for a time of 4 seconds. What is acceleration? Okay, cool. Fill in the blanks, you guys. Go ahead and do this by yourself. This is meters per second. Okay, so 50 divided by 4 is acceleration equals 12.5. But I don't know what acceleration is measured in, so I'm going to go back up, find acceleration, meters per second squared. So you go ahead and do that. There it is. Meters per second squared. Now I'm done, my answer. Awesome. You could try this acceleration one all by yourself since we just did one, so you could pause it and go ahead and do it. Hockey puck traveling, so we have acceleration, we have velocity, we have time. So this is meters per second. Okay, so again, if you don't know what this unit is, you're going to have to go back and take a look. I know that that's velocity, so 10.0 meters per second. Coming to rest in 0.0300 seconds. I know that's time. And then what's the magnitude of the puck's acceleration? So what's that acceleration? Okay, cool. So let's get her done. So A equals velocity, which is 10.0 meters per second, divided by 0.0300 seconds. So 10 divided by 0.0300. So the acceleration equals 333.3, and if I'm checking correctly, acceleration is measured in meters per second squared. Meters per second squared. Bam. Okay, this formula here, work, you saw in grade 8. So work equals force times distance. We actually did this together in grade 8 for a whole bunch of times. And so we've got the force is always measured in newtons, the distance is always measured in meters, and so we're going to do, again, our little chart, W, F, oops, and D. You guys can totally figure this out. If you pause this yourself, you can see if you get it right. We don't know. We've got 15.95. We've got 15 meters the first time, and then I think oh, and it lifts it too. So there's two calculations that we're going to do. Okay, so I'm going to do both of them. Work equals force times distance. I'm looking for work, so I go 15.95 times 15. 95 times 15. That's 239.25. Work is measured in joules. And then I'm going to do this one. 15.95. 0.575. 9.17, whatever, joules. Cool. And guys, this is the last one. EP equals mass times gravity times height. So we're doing potential energy. This is a grade 10 question again, one of the more complicated ones. So the sign is this many meters above the ground. So H is height. So I'm just going to write these down. M, G, H. Okay, so 3 meters above the ground is height. So 3.00 meters. Cool. So I've done that, and it has this much joules. Joules is always energy, you guys. So 1.47 times 10.3 joules. Calculate the mass. Oh, okay, cool. Now, I have this gravity deal, and I don't have a number. But actually, gravity has a number, and it's on here. If you guys take a look all the way up to right here, this letter G. Look, it tells you magnitude of acceleration due to gravity is always 9.81 meters per second squared. So I go back down here, and I go 9.81 meters per second squared, and I fill in what I know. Okay, here's my formula. EP equals mgh. Here we go. 1.47 times 10 to the 3 equals mass, which I don't know, gravity, put it in brackets because you're multiplying, times the height. Okay, guys, now what do I do? Well, I can do some math here. I can calculate these two. That's multiplying, so I can get that answer. So I'm just going to drop everything down. 1.47 times 10 to the 3 equals mass times 9.81 times 3 is 29.43. And so then I can just get the ML by itself by dividing. See how I did this, guys? So I'm just going to divide this number out. I'm going to go ahead and do that. Divided by 29.43. I get 49.9. Cool. And what am I measuring for? I'm getting M. So calculate the mass. Well, mass is always measured in grams. And so that is, your answer. And that is physics. So hopefully you guys went through this and you do good and rock grade 12 and 10 and 11 and 13.